It's about two girls from the same school in Leicestershire who were both 15, both sexually assaulted and both murdered. But there were 3 years between the killing.
Colin Pitchfork is a double child killer, a serial rapist, stalker, and serial flasher.
The crime took place in the quiet rural villages of Northborough and Enderby, located in Leicestershire, United Kingdom. At the time, the small community deeply shaken by two horrific unsolved crimes that occurred 3 years apart. The police were under immense pressure, facing a serial predator with absolute knowledge. The tragedy involved two young victims. Firstly, Linda Mann, murdered in 1983. On the evening November 21, 1983, 15-year-old Linda was walking home from a friend's house. She took a shortcut along a secluded path known locally as the Black Path. Tragically, she never made it home. Her body was discovered the following morning. She had been brutally assaulted and struggled to death. Another victim, Dawn Ashworth, murdered in 1986. Nearly 3 years later, on July 31, 1986, another 50-year-old girl, Dawn Ashworth, was walking home late in the afternoon. She took a familiar rural path near 10 Pound Lane. 2 days later, her body was found in a nearby field. The medical examination revealed an identical, terrifying pattern that she had been also assaulted and struggled to death.
The body discovered this morning by police in Enderby has been identified as that of missing schoolgirl Dawn Ashworth. 15-year-old Dawn went missing 2 days ago after failing to return.
Following the discovery of both victims, the police forensic team immediately searched post-crime scenes to find anything that could lead them to the killer. The most important evidence they found was biological fluid, specifically semen samples left behind by the criminal on both victims. The police carefully collected and kept these samples safe, hoping it will help them identify the suspect. However, we have to look at how limited forensic science was back in 1986. DNA testing didn't exist in police investigations yet. The best technology they had at the time was traditional blood typing. When scientists tested the semen samples, they could only find out that the killer had type A blood. While this info was helpful, it was way too broad. Type A blood is very common. It matched about 30% of all the men living in the UK at the time. So the police still had thousands of possible suspects and no clear way to pinpoint the exact killer. Because of the pressure from media, soon they found their first major suspect, a 17-year-old local teenager named Richard Brooklyn. Brooklyn worked as a porter at a hospital nearby, and he knew all the quiet paths and shortcuts where the two girls were attacked. Now, this is where the story takes a very strange turn. After being questioned by the police for a long time under heavy pressure, Brooklyn's mind broke down. He gave the police a detailed confession, admitting that he was the one who raped and murdered the second girl, Dawn Ashworth. The police thought they had solved the case, but there was one big problem. Even though Brooklyn confessed to the second murder, he strongly denied having anything to do with the first murder of Linda Mann. The way both girls were killed was exactly the same, means one person must have done both. And that is exactly when the police decided to do something that never had been done in history. They turned to the DNA scientists for help.
In 1985, Professor Sir Alex Jeffreys and his team at the University of Leicester developed a new technique called DNA profiling, also known as DNA fingerprinting. During the investigation, forensic officers collected semen samples from both crime scenes. The police then asked Sir Alex Jeffreys to analyze the evidence because they believed that the same offender had committed both murders. At
At that time, DNA profiling had previously been used in paternity and immigration cases, but this was the first time it was used in a criminal investigation. The police had already arrested Richard Buckland, who later confessed to the murder of Dawn Ashworth. Because of his confession, investigators believed that the case had been solved. To confirm his involvement, Sir Alec Jeffreys compared Buckland's blood sample with the semen samples collected from both victims. After the analysis, Jeffreys found that the DNA from both crime scenes matched each other, proving that the same man had killed both girls. However, the crime scene DNA did not match Richard Buckland's DNA. This clearly showed that Buckland was not the murderer. As a result of the DNA analysis, Richard Buckland was released after spending 3 months in police custody. He became the first person in history to be cleared through DNA profiling. DNA evidence prevented a wrongful conviction and allowed the police to continue searching for the real offender. This case became very important because it was the first criminal case where DNA evidence was used to prove that a suspect was innocent. Because of this case, DNA analysis is now widely used in forensic investigations around the world. Overall, this case demonstrated the reliability of forensic DNA analysis and revolutionized modern forensic science.
To identify the killer, police launched the world's first mass DNA screening. Every male resident in the local area, nearly 5,000 men aged between 17 and 34, was asked to provide a blood or saliva sample. Knowing his DNA would convict him, Colin Pitchfork actively avoided the test. He used manipulation and intimidation to convince a co-worker, Ian Kelly, to take the screening in his place. Kelly used a forged passport containing Pitchfork's personal detail, submitted his own blood sample, and successfully cleared Pitchfork's name from the investigation. The deception worked for 6 months until a breakthrough occurred at the local pub. A witness overheard Ian Kelly bragging about how he had taken the DNA test for Pitchfork. Recognizing the significance of this confession, she reported the conversation to the police in August 1987, exposing the flaw in the mass screening pool. In September 1987, Colin Pitchfork was arrested. Police immediately obtained a gene sample of his DNA, which provided a flawless match to the biological evidence left at the crime scene. Confronted with the absolute certainty of this genetic profile, Pitchfork confessed to both murders. In January 1988, Pitchfork was sentenced to life imprisonment with a minimum term of 13 years. He became the first murderer in history to be convicted through DNA evidence. Under UK law, a life sentence lasts forever. Even after serving his minimum term and being briefly released on parole in 2021, his suspicious behavior quickly violated his release condition. This triggered an immediate recall back to prison, where he remains behind bars until today. This case changed forensic science forever. It proved that DNA profiling actually worked in the real world. Most importantly, it showed the double power of DNA technology. It cleared an innocent man who had falsely confessed, and it perfectly identified a hidden killer who thought he got away. It set the gold standard for modern justice.